In this video, we're just going to look at difference of two squares, which are a type of expression that we might get and be asked to factorize. The best way to go about explaining how these work out is by first of all looking at our general rule over here, and then we'll have a look at a couple of examples to try and see this out with actual numbers and letters attached to it. So the general rule for this is that if we get an expression where we have x squared minus y squared, where x and y could be anything that just happens to be squared, so some number squared minus some other number squared, the factorization of that would be x plus y multiplied by x minus y, as you can see up here in the red square. But what we're going to do now is we're going to have a look at these as actual examples so we can see how this works out. So in our first example here, we've got x squared minus 16. Well, in this case, that x squared is already a perfect square, so we're good for that. But our 16, that's actually 4 squared. So we've got now is some number squared minus some other number squared. And based upon our rule for factorizing that, if we were to factorize this out, we would get x plus 4 multiplied by x minus 4, like that. And let's just see that again so we can see what's going on. This time we've got p squared minus 81. Well, p squared is a square, that's all good. And 81 is actually 9 squared. So we have p squared minus 9 squared. So if we follow our rule here for this, then it's going to be p plus 9 multiplied by p minus 9. And just incidentally for this, if you were to write as your factorization for this, p minus 9 multiplied by p plus 9, that's absolutely fine, because it doesn't matter what order you multiply things in. It would only matter what order you divide them or what order you subtract them, but addition and multiplication can be done in either order, so that'll be fine as an answer there for that. But those two are fairly straightforward difference of two squares. Let's take a look at what happens when it gets a bit more complicated. So in our first example here, we've got a number and a letter attached together for our second term. So we're going to have a bit more involved in what's going to be squared for this. So from this expression here, we have x squared, and then 16 is 4 squared. So 16y squared could be, if we do this, we put 4y in brackets, squared. And the square would apply to everything in there. So 4 squared would be 16, and y squared would be y squared. So we would get back what we started with. And then from here, we'd follow the exact same rule as before. We'd have x plus 4y times x minus 4y. But that's when we have a number attached to one of them. Let's just see what happens when we have a number attached to both. So it's a bit more complicated again. So this time we have 36x squared minus 49y squared. Well, 36x squared is 6x all squared. And 49y squared is 7y all squared. So our factorization for this is going to be 6x plus 7y times 6x minus 7y. Like that. But let's step up complicated even further just to see one of the more difficult ones. In this one, we've got 2 letters in each expression and a number attached to both. So this is going to get a bit more complicated again. From our first one, we have 81 h squared k squared. Well, 81 is 9 squared, and then we can then write that as 9hk all squared. That's going to be minus, and then 25 is 5 squared, so we could rewrite 25p squared q squared as 5pq all squared. And then from here we'd follow the exact same rules as before. So we have 9hk plus 5pq multiplied by 9hk minus 5pq. That's how you factorize the difference of two squares.